Hey guys, so we're going to continue where we left off. Example 17 now. Let's just go through this. I'm going through some problem for some reason. Oh, it's underneath the chair. Dang. It's a little bit unfortunate. Does that make it straighter? I don't know. Oh well, we're just going to have to sit like this. Rock is dropped from 80-meter cliff. How long does it take? Reach the floor, we did that. Baseball is thrown straight upward with initial force of this. How high will it go? So we know acceleration will be in the downwards direction. Let's assume that the downwards direction is positive. And velocity initial is equal to negative 20 meters per second. Final will equal to 0 meters per second. I do not know time. We need change of x. Okay, or we also need x final, but since x initial is equal to 0, this is going to be equal to that. Acceleration is equal to 10 meters per second squared. So given this, we can find VF squared equals V initial squared minus 2 change of x. Since we know V final is equal to 0, we can find this way. Find this to be negative 400 divided by 2. I forgot the A, but 20, which is negative 20 meters in the upward direction. And let's just see if that makes sense. I mean, that makes sense because it'll slowly go down. I think it would be 25-ish, though. I guess not, though. So we found the same. Just thinking about it, like, since it's per second and not instantaneously, the decreasing of velocity, we don't look at it each second box. It's like, oh, it's 20, then I'll go to 10, and then I'll go to 0. No, that's incorrect. Instead, we start at 20 meters, we go down to 0, and the area underneath this is which we are finding the position, and that is 10, or 20 in this case. Very interesting in my case. That's better. Okay. Finally got it. 1 second after being thrown straight down, an object's falling with speed. This, how fast will it be falling? After 2 seconds, if it was traveling this. Okay. So now V initial. Let's assume that after this is throw velocity. Let's make this our V initial. Because we're looking after it was traveling 20 meters per second. If it asked us after the first second, then we would have to probably choose a different V initial. But if we choose V initial being 20 negative, so it's all going in the negative direction, so we could just do 20 meters per second. And t is equal to 2 seconds. Average velocity will be equal to 10 meters per second squared. Thus, by using this information, we can use V final is equal to V initial plus AT, and then if objects thrown straight upwards with initial velocity of speed 8 meters per second takes 3 seconds to strike the ground, from what height was the object thrown? So at y initial is equal to this, y final equal to 0. We know the projectile looks something like this. So in this direction, we'll choose this to be positive, and so v initial will be negative. We don't know, and the acceleration is 10 meters per second. So we can do this as a two-step problem, starting to see what the v final, x final here. Then after finding this, we can find this value over here. And taking this, we can take this and subtract it from the whole thing to find this value that we're looking for. I'm trying to see what would be another way to do this. Yeah, I'm not sure another way to do this, honestly. If they were asking us for the final velocity, then we could simply just use this value over here to find the final velocity, since the velocity will be the same at both of these points. I'm trying to see. I think that's the only way we do it. Assuming VF is equal to 0, okay, for part 1, then we can say using our equations, I think I'm gonna look. Is it actually that far from the 5 equations? Wow, okay, I didn't forgot. So these are our 5 equations, right? We have V initial and V final, so use this for sure. I'm trying to see if there was anything else that we could use. We could use this, but why? We don't have X initial. Makes it really complex. Okay, using this VF is equal to V initial plus 2 change of X times A. I'm just going to check the solution, making sure we're doing the right thing. So they use this equation. I think they use the two equations to make some sort of, let's see what they do. I'm going to take a different route. Okay, the figure below shows a path for the ball. Not all motion is downwards, therefore A is negative G. We make it positive. In this case, you find Y, which is use big 3. So this is actually a very smart solution. I like it. So this is what I try to do, break it. It might be tempting, but we don't need to. So I think just going back to this equation sheet will be really helpful. Because, yeah, I'll just remember change in X is equal to V initial times T plus 1/2 AT squared. Does that make sense? Makes sense, I guess. Since we're finding this value, always draw diagrams because they're helpful. Projectile motion, now we'll probably have 2. Also have launch angle. Parabolic usually. Simplify, we will analyze horizontal and separately. Usually horizontal is easy. Okay. This is where you find the time. In X direction, Vx and Vx initial 0. Acceleration is usually or always 0. I think if there's air stuff, then it's going to change, but like whatever, we don't care about that. And then we have x initial times t equals, v initial times t is equal to change of x, because, these are equal. Then we use all the other stuff, other equations for y. I'm not read for this because my throat allergy is second. Okay. So it's saying how we can break up each of these quantities. So V0x, that means the specific VOX cosine theta and sine theta for these relevant quantities. Okay, object is thrown horizontally off a cliff with the initial speed of this. Car will drop in 4 seconds, assuming it doesn't hit the ground first. It's simply 40 meters per second. Since there's only V0 in the horizontal direction, it doesn't talk about vertical direction. You can assume that all is in the, so Vx is equal to V initial, which will go 10 meters per second. And we know that change in x will equal to change of x is equal to 10 meters times 4 per second. 4 seconds equals 40 meters. Now I realize that this is asking a different thing. So this is asking how far it will drop. If we're finding the y, we know v initial will be 0 in the y direction since everything is in the x direction. You want y. Don't really know VF. I'm trying to change x. Start changing y. This is easy, so I'm not talking because 5 times 16 equals 80 meters. I guess it's negative 80. We didn't define our direction, always define. We will sometimes throw some random info. Just remember you're solving for the right thing. Like I did it wrong. From height of 100 meters, a ball is thrown horizontally with an initial speed of 15 meters per second. Okay, now this time you can use this equation. It's easy, right? But the height doesn't matter. Projectile is traveling in a projectile path total of 6 seconds. How's the horizontal velocity 1 second compared to same? Because it doesn't matter. Okay. An object is projected upwards with a 30-degree launch angle. Okay, with initial speed of this, how long will it take for the object to do this? So always remember to list our givens once we get a lot of stuff. Theta is equal to 30 degrees. So VI is equal to 40 meters per second. You can break that into the cosine and sine of that. I won't do that right now. So we're looking for the time. We're looking for Vx equal to 0. Specifically, Vfy equal to 0. Vx will equal to Vi. So V DIY, sorry, I Loki broke down for a second. This will be 20 meters, thank goodness. It's an ugly number. That's why I don't like cosine, because cosine 30 is like bleh. Okay. And so we want T, and this a change of is V final square VY equals V initial Isn't that the equation? No, we could just use V final is equal to V initial plus AT, right? You know that assuming all this is a positive direction, right? As we talked about, let's just assume all of this is positive. Using this to be negative 10. Sorry, I'm tweaking a little bit right now because it's at 130. 20 meters. So negative 2 equals. But time is always magnitude, so it doesn't matter. No, I move forward in 2 seconds. To hide this, we can simply just use the other equation that we had that I was using. Do this. So this is what it'll be. Okay. Be a full arc. And we know that nothing will stop it, so V initial will be equal to V final. What we could do is find it where it's equal to 0. And find the time it'll take to do that. Time is 2. Multiply that by Vx to get the total H difference. That makes sense. Okay. Trying to find a faster way. Yeah, okay, that's I think the fastest way. We do that. Givens P initial equals 60 per second, theta is equal to 60 degrees. VIY is equal to, dang it, this is the ugly one. I'm not gonna do this because of the ugly numbers, but interesting. Why is this 130? 30-degree launch angle. Okay, fine, I will do this one. Okay, 30 meters per second. We know that V final equals 0, which is equal to V initial, which is equal to 30 meters per second minus AT. Assume this is the positive direction. T squared. Square root of 3 plus or minus. Let's take the positive time. Is that right? This has to be made on purpose. Because then we do V. So 2 times 3 is equal to total. And then we take x, which is equal to the square root of 3. Something must have gone wrong, right? Drive me crazy. Not AT squared, that's not AT squared. Total time is 3, so it's 6. We do 6 over here times 2. The square root 3 coming in from cosine 30, right? That cosine 30 degrees was square root 3 over 2. I guess not. It's 260. Isn't that right? Might be bugging. This is supposed to be tweaking me, bro. That's right. Okay, we'll do these drills later just because I think we're in a pretty chill spot. But I don't know why scroll isn't working, so we'll just refresh that up. Oh, my head. Drama to the scene. Anyway. Okay, let's start with this next chapter. What is it called? Newton's laws. I'm gonna make in the next video. Thanks, guys.